Hi everyone, welcome to the comeback, I don't know, the return from hiatus of the virtual Star Party. I'm your host, Scott Lewis, and with us tonight we have a great collection of live views of astronomical objects plus some astrophotography. We have a PhD astronomer, and we're from all over the world, literally. So um, let's go through our panel first, and I'm going to talk about what the new format's going to be like, and we're going to be testing out some new waters and go from there. So with us, I guess from left to right on my side, Chris. How are you doing, Chris?
Half awake, but not bad.
Half
It's
awake. It's
morning
what?
here.
It's 3 a.m.?
Yep, yep, just gone 3 a.m.
Good morning.
Morning. Hello, Internet.
Hello, Internet. I'm Chris. Next, we have Gary Ganella. How you doing, Gary?
Hi everybody, doing okay over here.
Yeah, we've missed you. I've missed
I've
you.
I've missed me every chance I get.
You got to aim better. Joining us from Malaysia is Shah. How you doing, Shah?
Hi, I'm fine. How are you?
I'm doing good. I'm in the AC here in LA. It's nice and cool in here. Is it pretty warm out there?
Yeah, it's 10 a.m. in the morning. It's about 30 degrees at the
30
moment.
degrees?
Yeah,
No thanks.
it's hot and humid.
Yeah. And Shah's going to be bringing us the sun, since it is 10 a.m. out there. He'll be bringing us the live feed of the sun. And we also have Dr. Thad Zabo. How's it going, Thad?
Hello, doing well. Doing well.
And you'll be bringing not only the science, but also some of your own images that you've
Yeah,
done
I was
recently.
camping up on Mount Pinos last weekend with the astronomy club from Cerritos College, and in between trees could get some deep sky objects. So yes.
Trees.
Ah.
Brrr.
Yeah, Los Padres National Forest Rangers aren't too happy when you whip out a chainsaw and it's like, I need more sky. They're like, you need to get fined and put in jail. Okay, I'll put it away. Put it away.
No, I think that'd be a great horror film. The astronomer going through like a madman with the chainsaw to all of his neighbors. I'm not trying to murder my neighbors, just their trees.
Just their trees.
All right. Well, what we're doing tonight and for the future, we will be bringing in live streams from telescopes from across the world. As you see, we have a great international panel with us. But we're also going to be bringing in some astrophotography from our regular astronomers and new astronomers that might not have been able to join us in the past. So I actually have a bunch of them over here on my other monitor, which I'll be sharing out, that were submitted earlier today. If you got the event notification on Google+, that link is in there, and I'll be creating future forums for you to be able to participate and hopefully feature your images on the virtual Star Party. With those, afterwards, I will be collecting and creating a set of high-definition desktop wallpapers that we'll be distributing out with the cool little VSP logo and all that fun stuff. So first, I want to go to a live view while I pull up some images. So I know, Gary, you said you had some stuff lined up. What do you have for us today, Gary?
Oh, let me pop it over here. And I'm taking some pictures of things that are up in the sky now. So I've got some. So these are all with my scope.
Nice.
Most of them taken from my location in light pollution. This is the East Veil, Cirrus Nebula East, part of the Veil. And that is in, again, narrow band, so hydrogen alpha, sulfur, and oxygen.
Wow, that is amazing.
On that one, hydrogen is mapped to the red. So any green in there is going to be sulfur, and the oxygen is going to be blue. So there's a lot of things in there.
Now, correct me if I'm wrong, Thad, but this is part of a supernova remnant?
Right, yeah, it's the Veil Nebula. I'm thinking it was probably a Type 1A supernova because I don't think anybody's ever found a remnant, and Type 1As don't leave a remnant behind. Well, they leave a remnant behind, but no compact object. That's what I should say. Type 2 supernovae will leave a neutron star or a black hole, or maybe, if they actually exist, a quark star. But Type 1A is the white dwarf that blew up, entirely blows up and is gone. And I don't think anybody's ever found a remnant for the Veil supernova, meaning likely a Type 1A.
Nice. That's just fantastic. How long of an exposure did you say this was, Gary?
That one is only about 5 minutes in each filter.
15 minutes total?
Yeah,
Nice.
15.
And
It comes out real good.
Hyperstar, right? So.
Yeah, I'm f1.9. Let me. I'm going to pop up something else here real quick. Where'd it go?
It's over there. While you do that, I'm going to switch over to a submission that one of our tried and true astronomers that we all know, Mike Phillips, has sent in, and he's kind of a jerk for doing it, because not only did he shoot this, but he did a little animation. So I'm going to switch this over here. So this is a GIF of a bunch of images that Mike Phillips did of Mars. Now, I won't be making this into a desktop background because that's silly, but phenomenal job. I will put this up into the event page on Google Plus because it does allow for animated GIFs, but wow. It looks like Celestia. You know, it looks like I'm playing with it.
Here, let's do a comparison. Give me a second here.
All right, you do
that. That is gorgeous. Mike deserves a standing ovation.
He does deserve a standing ovation. I'm going to actually pop this in right now into the event page. So those of you watching us over on Google+, or if you're not on Google+, if you are on YouTube watching us, head on over to the Google+ link that you should be able to see on my name. I'll bring you to the feed, and you'll see that we're live with the link to the virtual star party. And you're able to see the live feed embedded there and also make comments in there. And speaking of comments, and I didn't actually do this because it's been a month since we've been live, you can interact with us in many different ways. So we are, obviously you can comment on YouTube, which is the easiest for me, and also on the Q&A app. So Q&A app is something that you can see inside of YouTube and on Google+. I'm already seeing a bunch over on my right-hand side of the screen of people's, let's see, like Eric Charland, saying that his withdrawal symptoms are already receding now that we're live. So that's a good thing. I'm glad that nobody has has like broken and stabbed things because we have not been live in a while. So Thad, what do you have going on that you're comparing to? Do you have your own animation?
Oh, well, this is my Mars globe, right? And so I'm just trying to get the tilt, right? Just trying to get the tilt on it right.
Yeah.
And let's see. So every once in a while, so here comes. I'm probably going backwards compared to how it actually shows up, right? But there's Syrtis Major. Syrtis Major just went by on Mike's animation. I mean, it's really incredible just how much detail he has in there, because if you know how large Mars appears in the field of view in a telescope, it's tiny. It is really tiny. And so his ability to draw in this much detail is really just incredible, especially because Mars's rotation rate only being 40 minutes shorter or longer than Earth's rotation rate, night after night you end up seeing the same feature. You really have to get features spread out over a span of about 3 weeks or so to be able to see a full Mars rotation if you're shooting at the same time every night. Now, thankfully, back in April, Mars was at opposition, so you could get, about a third of a rotation throughout a night or so. But still, you have this kind of disadvantage of our rotation rates almost, being the same. So if you shoot at the same time every night, it doesn't look very different. So
right.
He really had to put an effort over multiple weeks to be able to get this much detail and get a full rotation of Mars. It's not like Jupiter where you sit there and it's like, oh, the thing rotated halfway around in 5 hours.
Right.
You really have to plan to be able to do this with Mars. So even more impressive that way.
He is just a beast. I mean, as we all know. I do have a comment here from Ronald that what did he use? So with this new form method, I actually have it all lined up here with me, especially if they're not able to join. So he was using a Flea 3 camera with his telescope out there. Wow, blows me away. And we have some more from Mike as we go on, but I'm going to head on over to James, who silently joined us like a ninja.
That's what I do.
Yeah, way to be on time. Way to be on time.
Yeah, it took me. It actually just got dark enough for me to get a 3-star alignment whenever it was 9 o'clock
Giving
here.
you a hard time, man.
Yeah.
But welcome back, and what are we looking at?
We're looking at the beautiful and the enemy. Moon action.
Moon action. And
Moon
we can
action.
see that it's real.
Because my
It's
cursor
not
just went across it.
Yeah.
Ah!
It's not made of cheese. So,
Are we sure?
looking at this here along the Terminator, so that's where the light and dark side kind of meet. What is that string that we're seeing along there, Thad?
Let's see. Let me
is that
get
a
the picture
Jekka?
out. Just sharing this out to my stream. Let's see.
I know
So
you did your research on galaxies. So
yeah,
I
but
know
with teaching the labs, I mean, I've got to get up on all of this too. That is the Apennine mountain chain on the moon.
Okay.
Right? So that kind of string of mountains, yeah, that's the Apennine. So that's between Mare Imbrium and Mare Serenitatis. So let me see. So the craters over to the side. Well, I guess I could cheat and pull up virtual moon atlas, but I would think Autolycus is one of them. Archimedes, and they're like 3 A names. I remember that because when my students label them, it's like, all right, well, if they have this 3 cluster and it's next to the mountain chain, they all have A names. But yeah, you're looking at the border between Mare Serenitatis and Mare Imbrium. Mare Imbrium would have the 3 large craters that are visible there. So.
And Mare means sea, so those are those big flat areas, correct?
Right. So we're sailing the seas of cheese because of the moon being made of cheese, right?
Seas of queso. Yummy. So I'm going to switch on over to Shaw's view, and then I'm going to actually hop over to Chris, or an image that Chris submitted as well. So this is live sun. We are looking at our closest star, the sun, live, and this is a nice set of sunspots going on. What are you observing with today, Shaw?
Sorry?
What are you observing with? What your telescope and camera?
I'm using the Skywatcher 120 mm at a focal length of 1,800 mm. Yeah. And the clouds coming in.
And the clouds.
Of course.
Well, we're gonna wait for that to fade out for a second, or we can all dance at once. Everyone watch and start dancing and do the no cloud dance. That is something that astronomers do to make sure that, most often unsuccessfully, but I think we succeeded. All of you out there that did the dance just now did make those clouds temporarily go away until they come back.
We need to stop sending clouds invites to these things.
Yeah, I can't help it. Everything's on the cloud these days. Everything's on Google Drive. It's on my cloud drive. And I think automatically it brings it in.
That's amazing, Shaw.
Yeah.
Yeah. So the 2 groups that we have at the moment are 2110 and 2108. So that's the one that we are looking at. And on the lower right, lower left, that is the 2109. So I can barely fit the groups in the view. It's huge.
So how big are we looking here? So if I'm not sure how, you said you had a really long focal length, which means that we're looking at something pretty small on the surface there. But what is the size of these sunspots that we're looking at? You have any idea?
The view across that we're looking at here, I just went to spaceweather.com and pulled up the image today of the sun, and it is extremely busy. Either one of the darkest areas of those spots, you could drop about 4 Earths, or about 3 Earths into each one of the darkest areas of those spots. If you take the whole group from side to side, you're looking at something that stretches about a span of across 11 or 12 Earths.
And which would terrify Chris's neighbor.
Yes.
Would terrify. We had a bit of a conversation beforehand talking about how his neighbor is terrified by the fact that, these factoids that this little thing that we're looking at is larger than our planet. And I'm going to switch on over to an example of that Chris submitted for us. And this is his submission, or one of his submissions, of the sun that he observed in H alpha And can you tell us about it, Chris?
Yeah, I mean, this was shot just a couple of days ago. As you can see, the sun's pretty active at the moment. And actually, my neighbor came to look at that prominence on what's my right-hand side. Yeah, just there.
Right there?
I was explaining to her that is, material ejected from the sun that is larger than the Earth itself, and that kind of stuff. She worries about. Bless her. She's this lovely lady, but that kind of stuff terrifies her. But it is wonderfully active at the moment. I mean, I watched that group come round only about a week ago. It started coming round the limb of the sun, and as I said, the sun is amazing because it changes so much. You look at it day from day, it's different. So, that image is actually inverted as well. So the filaments that you can see obviously show up lighter instead of the darker they normally would do, just to kind of bring out the detail.
Right. No, this is great.
That is a terrific shot, yeah.
And I love here on the top too, right there.
I mean, that's 4 images effectively. So you've got 2 to do the disk detail, and then 2 to do the prominences. So
actually, Scott, can you click, because it looks like you get a little spot or something there when you click or something. So yeah, can you do that again? Because essentially that spot is a pretty good representation of the size of the Earth relative to the sun.
Right where?
Right. Okay, so you see how it turned into a spot as you were moving the cursor around?
Nope.
Or is this just an effect that I'm getting?
Might be.
Okay. Well, if anybody else is watching this
tell
and
us about your imaginary spots.
So, they're all just swimming around me now. But anyway, if anybody else is watching and can see when his cursor turns into a spot, that spot is a pretty good representation of the size of the Earth. Actually, it would be a little bit bigger than how the Earth would look compared to the size of the sun. So there it was again. Okay.
The arrows is what you're talking about.
Okay, yeah, okay, so when it goes to the arrows. There we go.
Okay.
Yes, so when it does that, yeah, that's actually just a little bit bigger than the size of the Earth compared to the size of the sun. It takes 109 Earths to go across the diameter of the sun.
The virtual star party, here to scare old ladies all over the world.
And any other heliophobes. So.
Those heliophobes. Oh, man. I'm going to hop back over onto Gary, and as Gary's next image comes up, what are we looking at, Gary?
This is in the sky, a program called The Sky. I'm showing you where it is in the area it takes. The purple square is the field of view of my telescope, and this nebula is all in this area. It's huge in the sky. I want to show where it was. Now, if I back out a little bit, you can really start to see the size. Here's the North American Nebula over here. And I'm down at this point to pretty much the whole sky. So this is a big thing in the sky. My scope's got a wide field of view. I'll bring the picture up again so we can see that.
Yeah, answer a real quick question here on YouTube. No, Matt, we will not be looking at Pluto tonight. Unfortunately, I think we've only been able to do that once, maybe twice, and that was very difficult because it is extremely tiny and far away. So it took a lot of careful planning to get that done. But we will try in the future, definitely.
So this is the shot that I did.
Yeah.
In the 3 colors. So just want to pop that up and show how big this whole complex is. It's something that blew up a long time ago.
Do you know that off the top of your head? It's fairly recent. I mean, when we think about it on the scale of the universe.
Right. I mean, anything where you can still see a supernova remnant pretty well, because the explosions here are so violent, they really tear all of that material out into space and spread it apart very effectively, really quickly. So we're looking at something that's less than 10,000 years old. But no, I don't think there was any historical or prehistorical record of the supernova that caused this. If you look at the size of it on the sky, too, I mean, we're talking something that's multiple full moons across, from one side of the supernova remnant to the other. You're looking at something that's about 8 full moons across, and at the distance that it's at, I mean, this thing is enormous at this point. What's even kind of more interesting, what we're doing here, this is a visible light picture. If you look at this, say, in X-rays, you can see that it's a ball, but it's where the gas is hot. Well, it's not even hottest. It's hottest where the X-ray glow is, but it's slightly denser, and there's more of the kind of transitions in the atoms that give off visible light just around the edges. And so if you look at Gary's view in the sky again, right, you can see it looks like kind of like just this kind of outline of a bubble. Again, do it with X-rays, you can see the whole bubble, but it's just these kind of thin little filaments around the edge that make up the visible light portion of the supernova remnant here.
Now, this material is thrown off at a significant percentage of the speed of light, is it not?
Yeah, typically when a supernova remnant starts expanding, it's expanding at about 10% the speed of light. So, I mean, as this starts to collide with the interstellar medium, it will slow down some, but you can consider it going at about that speed for, you can look at that as multiple centuries after the explosion occurs. I mean, with the Crab Nebula, you can do this by getting pictures that were taken, say, in the early 70s, compare with pictures taken in the mid-90s or early 90s, and compare with pictures taken within the past year or two. And you can see, for instance, the Crab Nebula change shape and size over just 40 years, even though the thing is multiple light years across, just because of the violence involved in the initial supernova detonation.
So if this happened 10,000 years ago, these pieces of this could very well be a couple of thousand light years apart.
If it happened 10,000 years ago, then let's say on the order of maybe hundreds of light years, which to my mind sounds too big. To my mind, that from what I know of this, if it was that size, it would have spread out enough that we wouldn't be able to see it anymore. It would just be too thin.
Okay.
So it could be that it's in a very dense area where there's a lot of interaction with the interstellar medium and it's slowing it down. I might have the timing of it incorrect as well. So if anybody wants to pull up a verifiable source and call me out on this being kind of trying to talk off the top of my head, feel free to do so.
Words.
So
words. God. Actually, probably about a month ago as well, Dr. Katie Mack and I were talking supernovae and supernova remnants in particular over on one of my other channels, Space Fan News, and we were able to go into a lot of what goes on within the astrophysics realm of these supernovae remnants and actually what caused them to go on, and especially when you're talking about pulsars, and whole lot of fun. And I could go on about it for a long time, but if you head on over to Space Fan News, you can look up for the conversations there we had with that. It's about half hour. And we created a small little video about the Crab Nebula as well, which is another beautiful remnant. But we love talking space and astronomy and the science behind it, because it's not only beautiful, but getting into the nuts and the bolts of the science behind everything that's going on. I am very pleased to announce, too, that I am going to be sharing an image from one of our longtime fans. I think she's been a fan since the beginning. This is Helen, and she sent in her photo from her Orion 8-inch that she took with her camera phone, excuse me. So she took this with her Moto X, and let me pull up the particulars on here. She's got an 8-inch Dob, and this is, listen, what exactly Rupus Recta is. Rupus Recta, over here on the moon. So she took this over in Vermont yesterday. So Helen, we love your comments. We love that you've been with us for a very long time, and we love being able to finally show off the work of those that have been with us, but we haven't been able to have on live on the show. So I'm really excited that you've been able to take these images and send them into us, and we'll make sure to get some more, because I have another one here from you, I believe. It's in my big form of stuff. So what exactly are we looking at differently here than what we're looking at with James's view? Are we seeing anything different than that mountain chain?
Yeah, let's see. So where are we on the moon? So she said Rupus Recta, which would be not a mountain chain as much as like a scarp. So someplace where you see kind of a plateau of one higher than the other, and that's pretty well centered in this image. Let's see. So we're looking on the Terminator. And when did she take this photo again?
Yesterday.
Yesterday. Okay.
Yeah.
So let's see. So this would be a little bit farther to the east and probably south. There's that central kind of south central moon.
South Central?
Yeah, that's way different from South Central that we're familiar with here in LA.
Yeah.
But the kind of south central portion of the moon is really kind of wrecked with craters. Oh wait, I got this. All right, so down in the lower, so down in the lower left corner of the image looks like Alpertagius, Azrachel, and is it Thebit? Right, so Thebit. It's a frog on the moon. No, but it's but this chain of craters that's down in the lower left, it looks almost like a snowman, right? If you look at it, it's like a snowman falling over. And yep. So that
so like
chain
Kelvin
of
and Hobbes are over here acting out the big slaughter of snowmen, right?
Help! I'm being pushed over.
Yeah.
This is Snowman Sparta, and it's getting kicked into the pit.
There we go.
The pit here being part of, it looks like Mare, would it be Nubium, or Mare Cognitum, down on the kind of southern central portion of the moon. So okay, yeah. So having seen enough of this from my students looking at it, I'm pretty sure that's what we're looking at. So we're farther south, a good bit farther south along the Terminator than we were looking at the Apennines when we had that earlier image from James.
Yeah. Awesome.
Hey, well, can I share something? Can I? Please.
I guess it's your turn again.
Okay.
All right, Dr. Thad, share something.
All right. So like I said, I was in Mount Pinos last weekend, and I was shooting with both the DSLR, taking kind of wide shots of the sky, as well as with my 9 1/4 inch Edge HD, doing a bit of more of a close-up. So what we've got here, this is the Milky Way near Altair and Tara Z. So the bright star on the left edge of that image, that's
Can
Altair.
You rotate it 90 degrees? It's coming through in portrait in the landscape.
Well, it is a portrait shot, so.
Right.
I like this because north is at top, right? North is at the top in this shot. So I know it's okay.
This is video.
Yeah.
All right, everyone, tilt your monitors and your TVs 90 degrees. So Scott is taken care of.
I see it.
Right, exactly.
But yeah, Altair and the reddish star next to it is Tara Z. So that's Altair's part of the Summer Triangle, part of Aquila the Eagle, and then you can see this kind of rift in the Milky Way to the right of that. And so I thought, well, let's look for some dark nebulae. I don't think dark nebulae get enough love. This is where stars are born. Stars are born from these dark, dense clouds of molecular dust. And so I put a little green box around where the dark nebula appears in the picture that's a large portion of the sky, and then just kind of put it off to the side with the close-up that I got with the 9 1/4 inch scope. It's Barnard 143. Barnard had cataloged a large number of dark nebulae all around the sky, many of which lie along the plane of the Milky Way and are quite prominent during the summer. And so I thought this was just kind of a nice way of showing the scale of, well, this is what you would get with a DSLR versus what you get when you do a close-up with a telescope.
No,
it's oriented wrong. Okay, sorry.
No, you're fine. I will give you a hard time about it, though. I'm sure this is a very high-resolution image because it's having some difficulty rendering on my end. But will we be able to play with it later, or can you zoom at all? I don't know what image viewer you're using.
Yeah, let's see. I'm using Gary's bit here. So, where'd it go? Crap, I just lost it.
That's your face.
It's my face now.
That's your face.
The face nebula. Let me bring it back. Hang on a second.
Okay.
Here. And again, this is Gary's VSP program, so he can possibly. Gary, I'm calling on you for tech help. Please.
Yes.
Yeah.
Can you CSI that? I mean, zoom and enhance, please.
You just double click it, I think.
Yeah. Left click and move the mouse up and down.
Left click, move mouse up and down. Okay.
Or right click.
Let me drop this back in the hot folder.
Oh, yeah.
Bring back VSP.
And that voice coming up is Stuart Foreman,
Hi.
who's like, oh,
Hi, Stuart.
it's today. Yeah.
Yeah. Well, it was off my radar. Sorry about that.
For shame.
But I know.
So while we're waiting for that to come up, we should introduce you. And I actually didn't
Thanks.
get to introduce James either, even though I did poke fun at him too. But you were super late, so I got to make
I know.
more fun of you.
Absolutely.
But this is Stuart Foreman, another one of our long-term astronomers that we've been working with over the years, who's a doctor of a different color, I suppose.
Not an important one. It's not an important doctor like an astronomer.
Right, but he's important if you need to have a colonoscopy.
Yeah, there you go. I can do that.
Anyone with that power, you just
and I can image your colonoscopy too.
There you go. Wow, good. So Stu's up in Northern California, in the Bay Area,
Right.
and were you just sharing an image with us?
Yeah, I did. I was going to open up his Gary's program. I actually forgot about it. So, but I'll just screen share the shot.
Okay. And then when we're done, I will give you the link to submit your image for the future.
Okay. Alrighty. Let me just get it up again here. Full screen.
And then while Stuart said, James, let me actually introduce you. Where are you coming to us from?
Huntsville, Alabama.
Huntsville, Alabama, which is probably why the humidity is why we're seeing the seeing there in the moon. Because, Alabama's never humid, especially in July.
Oh, no.
How warm is it down there?
I know earlier it was 90. I have no idea what it is now.
Plus, 85% humidity, something like that?
Oh, yeah. Humidity is usually around 80 to 100, something like that.
Yeah, so you drink your air.
Hey, somebody's got to do it.
But he is bringing us a view of Plato and Mare Frigoris, and Hercules and Atlas are the craters. So Plato is the very dark, floored crater over to the left edge of the image. Mare Frigoris extends below it because we're looking at an inverted image. If you were to look at the moon and you had good enough vision to be able to see Mare Frigoris with the naked eye, you would see it at the top, or if you were looking with binoculars, that's how you would get it. But here, Mare Frigoris is below Plato, Mare Imbrium is above it, and then Hercules and Atlas would be the two large craters over to the right of it.
Very good. Love it. Well, I'm going to hop on over to Stu's image. Something that looks kind of familiar. What are we looking at, Stu?
This is something that's called the Western Veil Nebula, and it won't be up for high for another 2 or 3 months. This is in the constellation of Cygnus, and it's also called the Witch's Broom Nebula. And if you can just sort of imagine it being a witch's broom with the star, and Gary might be able to tell me what the star is because I just can't remember offhand.
I don't.
Yeah. But this particular image was taken hydrogen alpha, and it's one of the few hydrogen alpha images that I've done. I was basically doing it just to test the filter. This was just 45 minutes, three 15-minute subs in bright skies. I think a moon was out at this time. And it just shows how hydrogen alpha just can be a really, really cool technique to just kind of get those really bright, wispy hydrogen alpha emission hydrogen nebula, especially in the summertime in Cygnus.
Yeah, there are a lot of emission nebulae throughout that region, and so what Gary's you earlier was showing is that you also have a lot of excited oxygen atoms here as well as the hydrogen. Not so much in the way of sulfur, but as the electrons drop from higher energy levels to lower energy levels, they emit this kind of characteristic red color, and so you can filter with just that color and then get this kind of image that Stuart's showing us now.
Mm-hmm. Yeah, and I think Gary and I have the same filter. Gary, do you have 3 nanometer or 5 nanometer filter?
I'm using the 3 right now.
Okay. Yeah, and mine is 5, and I chose the 5 basically because 3 nanometer is very, very small, and you need really long subs to get a decent image out of it. So.
Awesome. This is great. I've missed you guys so much.
Yeah, missed you too, honey.
This is awesome. So I'm going to hop over to another image that was submitted by actually, see, this is, pull up the names, it's my spreadsheet so wide. Let's see, this is from Jim Meeker. And hello, Jim. I've seen you throughout the inner tubes in our adventures with astronomy. And this is his submission using his Canon T3i of Jupiter. Is that coming through?
Yeah.
This, well, here. Maybe if I screen share not the full screen, but this. No? I'm seeing everything. Oh, I'm seeing Jupiter. That's why. I was looking at Stewart's view. So yes, here is Jupiter. And this is from Jim Meeker. Let me zoom in a little bit more.
So is that a shadow transit that we've got going on?
I believe it might be, or it could be dust.
It's round enough. Let's call it a shadow.
I'm going to call it a shadow. So that might be one of the natural satellites.
Yeah.
And this was taken with the Celestron Nexstar 8 and his Canon T3i, the same camera I have, which is an awesome camera. So,
very good.
What you're talking about Jupiter earlier? How, especially compared to Mars, its rotation rate. So how fast is Jupiter going around? How long does it take for a day to be on Jupiter?
So with one thing that's really different with Jupiter is because it is a gas giant rather than a terrestrial or rocky planet like the Earth or Mars. The equator actually ends up spinning a little bit faster than the poles. The equator spins once every 9 hours, 50 minutes. And the poles spin about once every 9 hours, 55 minutes. And so the whole planet spins in under 10 hours.
Wow.
And if you consider that it's, if you look at the size of that little dot, that shadow thing on Jupiter, the Earth would be a little bit bigger than that. It takes 11 Earths to make up the diameter of Jupiter. And so you think of this thing that is that much bigger than the Earth and spins at an angular rate that's almost 2.5 times faster. At a linear rate, it ends up being, something was 2.5 times 11, so it's like 40 times faster. The Earth's equator spins. If you're on Earth's equator right now, you're going around at a little over 1,000 miles an hour, a little over 1,600 kilometers an hour. If you were on Jupiter, you would be spinning, going around in the atmosphere at 40,000 miles an hour.
Wow. That's crazy. And Jim did just make a comment on the Q&A that it is a shadow transit.
All right. Yeah, you can even see a little bit of a festoon. So this is an inverted image, so south is at the top. And so the south equatorial belt where the shrinking great red spot lives is the broadband toward the top.
There you go.
Okay, now we got it right. So now south is at bottom and north is at top. And we've even got a little bit of festoonage, right? Some of these little blue extended features that are visible just under the north equatorial belt on this image. So that's a really nice shot.
Love it. Well, thank you, Jim, for your submission into this. And we're going to hop over to some deeper sky objects. I'm going to hop on over to Shaw real quick. This is not the sun. What are you looking at?
I'm sunless at the moment. The clouds are coming in. But this is the Omega Centauri, the globular cluster that I took last 2 nights, I think. Yeah. This is a very short 15-second subs, totaling about 5 minutes of using the 8-inch f4 telescope.
Why were they so short?
Because I'm too lazy to do guiding and things like that.
Also, with an object this bright, you don't really need very long subs to get a lot of detail. I mean, this is
usually you go longer than 15 seconds, though.
Yeah. You're too lazy.
Depends on f ratio, though, too. I mean, if I don't know what was your f ratio for this?
4.
It's f4, yeah.
f4. So yeah, at that small of a focal ratio, you don't need to have very long subs, especially not with an object this bright.
No,
Yep.
it's
Wow.
gorgeous though.
Yeah, an incredible amount of detail. Now, this is something where you'd have to be, all of our U.S. viewers, except maybe for a few people in Florida and Hawaii, wouldn't be able to see this on a regular basis. It barely clears the horizon for the southern tier of states, and if you're north of about, let's say, like Virginia, that kind of latitude, you never see it. It never makes it above the horizon. This is very much a southern hemisphere object. So Shaw is pretty ideally placed here, being in Malaysia and able to get pretty much the whole sky. I imagine there's some stuff around the North Celestial Pole and South Celestial Pole that never make it very high in the sky, but just about everything else you can get from that kind of latitude.
Yeah.
Lucky.
With clouds.
But the clouds, okay, yeah, aside from the clouds.
But I think we can forgive you on that because this is just beautiful.
Yeah.
Fantastic shot. Thank you.
Yeah, Tanya did a great one last year with her 60 DA in her refractor, which is gorgeous.
Well, now that we're doing more astrophotography, I sent Corey a message on WhatsApp, and hopefully he'll text me back when he wakes up. 'Cause it's like 4 a.m. out there in South Africa right now, so hopefully we can get some more from them. So I'm gonna pop over to Gary's view because wow,
This is the Triffid M20. Now this was taken at a dark location with a Canon 20 DA for 2 minutes. So it's a single. What am I trying to say? Colored chip. So I get all the colors at once. So this is true color.
That's a 2 minute. That's a 2 minute exposure.
2 minute, yeah.
Yeah.
wow.
It was at Bryce Canyon, so I was high and very clear skies, gorgeous.
Nice.
Very nice.
So what are we looking at there, Thad, with the Triffid? What exactly is that?
Well, there's essentially 3 types of nebulae that you can see kind of scattered around the Milky Way. So we're not going to count supernova remnants like the Veil, but you have emission nebulae, which is what's showing up in red. These are extremely hot, highly energized regions of hydrogen, and so they give off that characteristic red color from hydrogen alpha. The blue is from excessive amounts of dust, and so those are lit from the side, and then they scatter this blue light out to the side, much as if you look at the sky, the Earth's sky, not if you're on Mars or some other planet, just on the Earth. Right? This blue sky that we have is because those shorter wavelengths are preferentially scattered out to the side. So the same thing's kind of going on here, is that you have this dust, and it's illuminated from the stars that are embedded in it, but it scatters the blue light out to the side. So it's called a reflection nebula. And then you have these dark clouds that are embedded in there. These are the densest portions of dust. This is where new stars are forming. So you have the emission nebula in red, you have these dark dust lanes and other dark knots embedded within the nebula, and then you have the blue reflection nebula, which is more dust but thinner and kind of scattering light from stars around it off to the side of it there. So all 3 types of nebulae are represented here. So.
We represent all nebulae here. We don't judge.
And again, the 2 minute exposure makes sense to me because this is an exceptionally bright object. This is something that if you go too much longer than that, you end up oversaturating a lot of pixels pretty quickly. So it's about the right length to actually still be able to see those extremely bright stars in the middle of the emission nebula, and be able to capture the fainter details on the edges. So well done.
Yeah.
Thank you.
And how far away is this from you? The location you shot this at?
Oh, Bryce Canyon?
About 13 million light years? No.
Yeah.
Oh, come on, still within our own galaxy.
Yeah, I'm kidding.
That far.
You're asking me where it was shot, how far?
Yeah,
It's about
where it was shot.
About 700 miles, I think.
Okay. Awesome.
Yeah, it's a good, 11-hour drive or so.
It's a day trip.
Yeah.
Yeah.
Not
Yeah,
too
it's
terrible. I go camping afterwards, though. So I'm going to share a shot real quick. I had opened up here in Photoshop, but I don't know if it's going to load. There we go. Is that loading there?
Nice.
Mm-hmm.
So this is from Ahmet Kale in Turkey. So he sent this over to us. This is his Cocoon Nebula. And it just, beautiful. Absolutely beautiful.
Again, this region of dust and then the hydrogen alpha emission inside. What you need is some of these extremely hot, really massive stars to put out enough ultraviolet light to get those electrons jumping around in that hydrogen and give off that red glow. So anywhere you see an emission nebula like this, somewhere in there is one of the hottest and largest stars in the sky called an O-class star. Those are the only ones that dump out enough ultraviolet light to cause the transition in hydrogen that gets that red glow to happen.
I have another one from him, which I'll put out later because we are running out of time when I get to our live astronomers. But thank you, Ahmed. And we'll be putting, we'll be taking these images and putting them and compiling them into a package for everyone to be able to use later on for wallpapers, and I'll put them up on the event page too. But I am going to hop on over to James once more to take a look at our lovely lunar face. What are we looking at?
Looking at Mickey Mouse on the moon.
Oh boy, I'm on the moon. So what is really Mickey Mouse on the moon? What are we looking at?
Well, again, that's that snowman we were looking at before, right? That it's
No, this is a completely different area. This is what we were looking at before was way up here.
Oh, I'm sorry, but the same as
Helen's.
As Helen's, yeah. This is the same area as Helen's shot that we were showing earlier. So.
Oh, okay, yeah.
Yeah. So sorry. Yeah, not stuff that you were showing previously, James. But yeah, this is the same region that Helen was showing us. So with Alpertagius and Azrael, and I think that's Ptolemaeus is the other large crater. So those three make up Mickey Mouse, and Disney is everywhere.
Everywhere, permeating our lives. Now, what I love here on the very left-hand side, you can see where the geologic structures of the craters are popping up where the terminator is and catching sunlight, even though it's on the dark side. You can see it. Are you able to digitally zoom in there at all?
Yes, let me do that.
There we go.
Oops, wrong button. There we go. And let's make it a bit bigger here if we can. No. Yeah, it's not a good idea. There we go. So, yeah.
So can you go over to the left where the yeah, there we go. Right there. I love that. So we're seeing the terminator where it's becoming nighttime, or actually what
becoming daytime.
Right,
the sun is rising.
Yeah, that's right. So it is rising. So this is popping up. And it's just like when you're seeing, if you're in an area on Earth where you have mountains around you, you can see where the mountains start getting that sun before the rest of your surroundings, and that's what's happening right now on the moon. And that's just awesome, because I know for me, when I look up and I see the moon, it's very easy to think of it. It's just this circle, or just this 2D thing that floats up in the sky. You just take it for granted. But looking at it, and you're seeing how dynamic it is, or used to be very active. But you're seeing this awesome, beautiful structure, and just imagining what sort of energy went in with those impacts that caused that sort of terrain.
Yeah, because the larger craters there are on the order of 40 to 50 miles across. So we're looking at things that are 70 to 90 kilometers in diameter for the larger craters in that view.
So big bada booms.
Big bada booms.
Big
and
bada
it doesn't even have as much gravity as the Earth. So this is something that had been traveling through space fairly quickly. On Earth, if something ends up in Earth's gravitational field, the last bit of its journey, it's going to pick up a great deal of kinetic energy because of Earth pulling it in faster. Now our atmosphere is going to burn off a good bit of it, but something big enough, well, just ask a dinosaur about what happens.
Right.
Big enough.
What happens?
Gets caught. No have large enough arms to type answer. But so the moon, this has had to be something cruising through space pretty quickly to be able to smack into the outer layers of the moon and cause this kind of crater. So.
Oh, that's great.
Yeah.
So, Chris, you can screen share stuff. Did you have not fifth soul, but the soul?
The other soul.
The other soul. S-O-L.
If
But
I can
not
remember
that
how to...
S-O-L. That's not what I'm meaning.
1 second.
Soul as in sun.
As in Helios, as in the big glowy thing in the sky.
So as you're pulling it up, I'm going to share another image here because we are running out of time. This is from, I believe, Stephen Ron, I want to say is his name. It's on another tab. Should probably pull that up. Yes, Stephen Ron. And this is Venus and the Moon. No telescope, actually, sticking with the 60D in Georgia. This was taken at the very end of June, June 24th. So this was a little while ago, but I love what he did there, where you're seeing that the sunlight reflecting off of the moon, it's really blown out just so we can get the Earth glow on the moon, and Venus really bright out there.
Yeah, so you have two objects here where the light is being reflected off. They're directly, so sun, reflect off object to Earth. So that would be Venus and the bright crescent part of the moon. But for that kind of shadowier part, the full disk, that's sunlight hits the Earth. Earth reflects it back into space, it hits the moon, and then comes back to Earth again. So if you think of how bright the full moon is in Earth's sky, the full Earth in the moon's sky is about 50 times brighter than that, and so that's what's causing the glow that allows us to see the full disk. So yeah, Stephen's done a lot of really great lunar work recently. If you follow his Flickr account at all, he's done a lot of really great shots.
Very good job, and I know I've seen in the event page he has added some images in there, which I haven't pulled up since they're not in the thing. But if you are on Google Plus, check that out in the event page because I know he put at least one in there. But here's Chris's image. Ah, wow.
That is an awesome amount of detail. And then you have to think the smallest features that we're looking at here are about a quarter of the size of the Earth. Right?
Oh, is that all?
One pixel on here is about a quarter of the size of the Earth. And so any feature that you can see with any kind of extent is comparable to the size of the Earth. Again, why it scares his neighbor so much.
Yes. Why are you such a terrible person to your neighbor, Chris? Hey, look at this. We would die. Oh, I love it right there. I'm looking over on the image you sent over to me, that same image, and yes, I love that swirling tendril that we're seeing there.
Mm-hmm. Let's keep that 1.5 million kilometer distance.
Yeah, let's stay where we're at. Hopefully we can get our atmosphere without getting too out there with the greenhouse gases, so it's not terrible. But yeah, I like where we're at here, right here. This is good. So I'm going to hop on over to Gary to take a look at many, many, many stars.
Yep, this is M31, the Andromeda. And again, this was from a dark location, about a 5-minute exposure, and it is true color.
Oh, man.
And then it's 110 and I forget 32. What the other two. Which one?
32.
32.
Yep.
Or its companion galaxies.
You can even see some really massive star clusters within the arms of the Andromeda there. Yep, like exactly where you're pointing there. Just how much star formation must be going on to be able to get that kind of view from 2.5 million light years away.
And the dark lanes.
Mm-hmm.
That's really one of my better pictures.
That's fantastic.
Yep.
And it's headed right for us.
It is.
Absolutely.
Brace yourself. 3 billion years from now.
5, yeah. So this is the first. This is the first named galaxy, I suppose. It's the first one that we knew was an actual galaxy, because it used to be the Great Nebula in Andromeda.
The Great Spiral Nebula. Right. So this was the first one that Hubble was actually able to pick out individual stars in with the 100-inch Hooker telescope on Mount Wilson.
Yeah.
And making comparisons from many, many plates over multiple nights, he's like, okay, these stars are changing brightness. The rate at which they change brightness allows me to use Henrietta Leavitt's results to say this thing's got to be over 2 million light years away. So actually, I'm not sure if he came up with 2 million at first. I think he actually thought it was a lot closer than it was. But But yeah, this is the first one that was known to be a galaxy, and that knowledge is just a little under 100 years old, right? Because those papers would have come out in the early 1920s.
And if any of you guys get the chance to come to the LA area, it's just outside of Pasadena. You can go up and visit the telescope up there at Mount Wilson. It's amazing. I recommend everyone get a chance to go do that. And it's the history of astrophysics. It's where we started to really dig into not just the motions of things and having ideas about it, but finally getting into the physics of what's going on up there. And I love it. Andromeda's, besides the Milky Way, probably my favorite galaxy. Besides the Milky Way, because we're at home here.
So speaking of some other galaxies, how about what Stuart's got here?
Oh, no, he's late. He doesn't get a second chance.
Okay, never mind then.
What are we looking at, Stu?
This is M81 and M82 taken about a week after we didn't discover the supernova. And this was a 4-hour exposure, so an hour of luminance and then an hour each of red, green, and blue. The supernova itself, can you see my mouse, is right there. So let me see if I can get to it. So right, this guy right there is the supernova, which is now, I assume, is gone. But at the time was really neat to see. I'd actually never seen nor imaged one before, and then everybody was imaging it, so I had to try to do it too. But the other thing about these two particular galaxies is, and you can't see it on this image, but there's it's called the Flux Nebula, I think it's called. But anyway, if you look at really, really super long images, this whole area is just filled with wispy interactions between the two galaxies. And if you look at Mike Chason's Google Plus page, he just has a spectacular one that he took from the San Diego desert.
The other way of bringing that out to show really well, as Nicole Gallucci would remind us, is to look at it with 21 centimeter radiation and look at it with radio waves, and then the interaction between them becomes really obvious with all the neutral hydrogen. Because the red glow that we see from emission nebulae, you need to have bright, hot stars around to get it to do that. Well, what if you don't, and you just have neutral hydrogen? That's where you got to look for radio waves and have this very low energy radiation that can come from basically the electron flipping from one spin orientation to the other and showing where neutral hydrogen is in intergalactic space in this case.
Such a great job. Well, we are running out of time, so I'm going to do a quick run through everyone down here on the panel and have some ending words here for everyone. So Chris, thank you for waking up and joining us.
Yeah, no worries, anytime.
Are you going to go back to sleep or get your tea on and go for the rest of the day?
Back to sleep, then back up imaging the sun.
Nice. And make sure to terrify your neighbor a little bit more. Yeah.
I do enjoy the doom. All the doom.
Awesome. Do you have a website or a place for people to follow you on social media?
Thanks to Fraser, I'm now on the Twitters, so you can get me at CKEMU. And then, of course, I'm on Google Plus as well, just as plus Chris Kennedy. So
fantastic.
So everyone, all my pictures there.
Give him a follow, and start nagging people on Twitter. It's become a lot of fun. I'm becoming addicted to Twitter. Gary, it's been a while. I need to come over and say hi.
Yes, you do. The invitation's always open. Thank
you. Amazing images. I'm really excited with our new format, so we can work with you on getting some. I know you've done some phenomenal long exposure work, so maybe we can talk after the show about some cool ideas with it. Okay. Absolutely fantastic job as always.
Thank you,
James. Late, but not that late. Not that late at all. Thank you.
Never too late.
No, that's right. Thanks for bringing the live moon. That was awesome.
Not a problem.
And I see you are here on Google Plus. Is there anywhere else on social media or a webpage? And I totally skipped Gary, so I'll jump back to Gary here in a second. You just on Google Plus?
This is the Google Plus guy.
Awesome. So find James. Do you put up any of your pictures?
Yes. I try to share them on the astronomy, the space community as much as possible.
Awesome. So follow him. Gary, are you just on Google Plus? Are you elsewhere? Are you on Friendster at all? MySpace?
Google Plus. That's the best place to find me.
Awesome.
Yep.
Hey, don't knock Friendster, Shaw. I saw you laughing over there.
Shame.
Shaw Gazer. Thank you for bringing us the sun and your Omega Centauri. Where can we find more about you?
Yeah, I can be found on Google Plus, yes, plus Sharin Ahmad, and as well as on Twitter, Shah Gazer.
And I know that you're involved in a lot of work, and you just put up a lot of great images too. So keep up the good work. Love it. Stu, and then Thad. No, I'm just kidding. I love giving Stu a hard time. I love it. It's just like it's my hobby.
Yeah, well, I'm such an easy target.
Well,
but at least I have hair. It's just
true. Yeah. You do have hair. As I tried to grow mine back out, I realized it's not there anymore, and so I'm just going to keep shaving it. Are you elsewhere besides Google Plus?
Just on Twitter. I should have the lower third up. I'm at S24MAN, so at Stu Foreman. Haven't been that active recently because my camera's been on the fritz, but my new camera's coming on Thursday, so I will be back in action.
Clouds.
So
yeah,
right, of course.
When you were texting me about it, we were texting back and forth about the ordeal, and I'm really happy that it's been settled.
Yeah.
And that
hopefully, So it's been an interesting experience, but if a camera was going to go out, this is the great time of year for us to do it because it doesn't get dark till like 10 o'clock at night.
Right.
So it's just
and you have a child and work
and so anyway.
And Dungeons and Dragons.
Right, and also it was galaxy season, and I have a wide-angle scope, and so it's sort of hard to image anything in galaxy season. Anyway.
Thad. Dr. Thad.
So yeah, you can find me mostly on Twitter and Flickr. Twitter at AstroThad. I've been posting a little bit more to Google Plus again recently. I had kind of too high of a load of classes to teach this past spring semester, so I'm not going to do that again. And so hopefully you'll find me a bit more around with the virtual star party and other kind of outreach events here on Google Plus and elsewhere.
Awesome. And me, I'm Scott. You can find me at Scientific Scott. I'm also Space Fan News and Deep Astronomy. And we have a bunch of events coming up. Let's see here as I'm pulling up my calendar. On Tuesday, we have the 100,000 YouTube subscriber celebration on our Deep Astronomy channel with Tony Darnell, and we're really excited about that. We've been anticipating this milestone, so we'll be having a live hangout on that. And then also on Thursday, the 10th of July, we'll be having a Hubble hangout. So we'll be talking about white dwarfs, and we'll be bringing in the science team from Hubble as well as some other astronomers in citizen science, and we'll be talking about that. So that is Thursday. So follow the Hubble Space Telescope, and we'll be talking more about that. With the virtual star party, so everyone was saddened and very disheartened about the fact that we're going to one show a month. What I'm going to try and do is I'm going to be creating another form here, and if I can get enough submissions from images that from everyone, from people that are normally in the show, that people that have been following us for, gosh, almost 3 years now, if I get enough, I will try to have another virtual star party 2 weeks from today. And then if I'm seeing that we're consistently getting a lot of images and we're still able to bring in the live feed every week, then we will try to get us back to the every week format. The biggest reason why we went to this is that we wanted a way to never have to cancel a show. And so as long as we have enough information, enough images to share out to everyone, That means we'll never have to cancel. Even if all of the Earth is covered in clouds at that moment, we still have something to share with all of you, instead of like, well, I would be looking at this, but there's clouds. We're just going to sit here for an hour and not do anything. So I will create that form later. I will share it out on the Virtual Star Parties Google+. I will tweet it out and put it up on my page. So thank you all for, I didn't even get to all the images for today. Your great comments and questions, I didn't even get to all those. So it's great to see that you guys are all excited to have us back, and we're excited to be back. So let us know. Comment on YouTube and on Google Plus if you have images. Want to get involved, contact us, and then hopefully in 2 weeks we'll be back. So we will see y'all later, and have a good night.
Thanks.
Good night.